Hey guys, so here is the second day of the video lessons that will be uploaded to YouTube. Sorry about yesterday's video. There'll be a few kinks I need to work out, and hopefully soon I can get it down to very little problems for you guys. So today we move on to section 4.2, the unit circle. I think every single person in the class knows this one, but two who I did not teach pre-calculus 22. So the unit circle is a very, very powerful tool that we will look at again. And then in the next few chapters, we're really going to try to look at all the ins and outs behind it. It will be coded on YouTube again as pc30 section 4.2.1. So chapter 4, section 2, day 1, and I'll stop writing down the code soon as you guys get it. So number one, where do the values on the unit circle come from? And you would want your unit circle out in front of you as you're watching this video. The unit circle comes from the special triangles, and I introduced this just slightly in pre-calculus 20. The two special triangles, the most maybe important triangles in the world, are a 30-60-90 triangle and then a 45-45-90 triangle. I'll put down 45 once here. It's kind of small to the right, and then I'll put down the 60. Hard to see, so I won't even try the other 30. These triangles were first of all discovered a long time ago, and the ratios were always the same. It didn't matter how big you were drawing a 30-60-90 triangle. The hypotenuse was always twice as big as the shortest side across from the 30. And then what they realized was this side, the middle side, in terms of length, was always root 3 times bigger, the smaller triangle. And no matter how big or small you drew the 30-60-90 triangle, it always came out the same. The 45-45-90 triangle, well, first of all, we know the name of this. This is isosceles. These sides are always the same. So they're said to be in a 1-to-1 ratio. If this side is 12, well, so is this side. And then what was discovered was that this side, the hypotenuse, was always root 2 times bigger. And then with your unit circle in front of you, you start to see where those values come from. And they can be confirmed. If we just look at this 60, sine. We've known for a long time that sine is opposite over hypotenuse. And if you went and said sine is opposite root 3 over hypotenuse, the 2, well, you look and you see root 3's over 2 all over the place on the unit circle. So the unit circle was developed again as a tool to just make calculations forward and backwards, which we started to introduce again in our previous course a little bit easier. Now, before we do that, what we need to do is just review what are the ratios. And yes, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Those will never go away. They're very good. But what we need to do is we need to develop a little bit of a different version. And you guys already know the letters. There's going to be no surprises. So what I'm going to do, just like the previous course, is draw an angle in standard position. So starting on the x-axis, doesn't matter how big you draw it. Technically, the ray goes forever, but we'll just drop it straight down to make a right angle, and then we label. When we are labeling, we've seen this before. We're going to call this side x, this side y. Makes sense, x-axis, height, y-axis. And then we're going to call this the r. We now know it's called the r because in the unit circle, we're looking at a radius, and so therefore we use an r, not a letter like z. And then if we just do the mesh together of SOHCAHTOA and also then these letters, we look at the angle, and if we look at sine first, sine is opposite over hypotenuse, well, therefore in these letters, it would be y over r. Cosine of this angle would be adjacent over hypotenuse, therefore x divided by r, and tangent opposite over adjacent, we would have a y over x. Now these are very important. You need to know these off by heart. Your previous teacher would have tried to pound those in. He never would have given them to you on an exam, because if you know those ratios, well, then good things are going to start to happen. Now, what we're ready for immediately is again to take a look at the unit circle. So what I want to ask is that you guys have a unit circle in front of you. I have a copy, and I'll put it in and I'll point at it here and there, and then I'll take it away so you guys can just follow along with what I am doing. So the final part of today's notes would be to go through a number of unit circle questions. And essentially the only difference now over this course and also then the pre-calc 20 that you did was now we know what radians are. We have a little bit of experience with radian measure. That is where all of the pi's come in on the unit circle that you were wondering about just one course before. So for number 3, the find each value, let's remember again that r is always equal to 1 on the unit circle. And so we start off with 3a, and it just says, what is the sine of 60 degrees? Well, this is an old one. We did this one in pre-calc 20, and you guys were quite comfortable quite quickly in it. We would start with sine is y over r, and r is always 1. I know that after a little while, even in pre-calculus 20, we stopped writing down r as 1. You will see immediately in tomorrow's lesson that r equals 1 is more important than we think when we look at, again, the reciprocal trig functions. So then this is how simple it is. What we do is we find 60 degrees on our unit circle, and remember it goes x first, y second in the coordinates. The y value is root 3 over 2. We go back to our question. We have root 3 divided by 2 over 1. So the over 1 essentially doesn't do anything, and we've just done it. We have found the exact value of sine of 60. It's root 3 over 2. And again, let's just say it once. The connection is this. This is the exact value. It's the exact same as if you typed sine of 60 degrees into your calculator in degree mode. But in your calculator, it would be a decimal, and most likely you'd have to round it off to write down. That's why this is called the exact value. It's the exact same as the decimal, just in a radical form. And in one way, I guess it'd be better because it's not rounded off. It is the perfect value. It's the exact value. And so then another review, I guess, cosine of 45 degrees. What becomes essential is that you've memorized these ratios. So cosine is x over r is always 1. And if you're looking into the examples in the PDF notes, I stopped writing down r equals 1. In this case, it's fine to do it. Then you will know when it's time to not worry about the r. And so then we find 45 degrees in the unit circle. We find the x value, and it's root 2 over 2. We do have a little bit of a bonus where you can make a mistake and mix things up, because at 45, both the x and the y are exactly the same. Also in pre-calculus 20, we moved into then saying, well, what if you had to find an angle like 120 degrees where it was not in the first quadrant? Here's where the unit circle really starts to show its power. In pre-calculus 20, if you were just using the special triangles, you had to use the special triangles, you had to use reference angles, and then you'd have to figure out whether it's positive or negative. Here's where the unit circle really starts to show its power. If we remember that tangent is y over x, well, then we can find our values at 120 and be careful. One of them might be negative. So we go around to 120. The y value is root 3 over 2, so that goes up top. Common mistake would be to mix up the x and the y values. The x value is negative 1/2. Now, in pre-calculus 20, because we got ahead of ourselves a little bit, I just said it's fine to leave your answer as follows, but now we can't. Now we have to fix it. We have to use the math that we know. So in this one, first of all, our final answer will be a negative. A positive divided by a negative is a negative. Then we are going to flip the fractions. And when we flip the fractions, remember, you have one fraction divided by another, keep, change, flip, divide by the opposite. Here's what it looks like, which is not in the PDF notes. What we would have is square root 3 over 2 as our first fraction, dividing by the other fraction. I've already taken care of the negative. Is really like multiplying by the reciprocal. So if you take the bottom fraction and flip it up, I've done that with my fingers before. Now what you see are the 2's canceling out, and the final answer of negative root 3 comes out. Now that might feel very, very familiar, and it should, because that was essentially pre-calculus 20. But now we get to move up. For our remaining examples, now we get to see how our new knowledge can come into play. So we could figure out what is the sine of 7 pi over 6. We could do it without a calculator, and one course ago you would have been like, what's 7 pi over 6? But now we know. Now we know that is showing radians. There is no degree symbol. The pi kind of hints at it as well. And this is again where the unit circle really shows its power. If you guys lap around in the unit circle, and let's first of all find, where is 7 pi over 6? Now here's what I think you should always do. Look at what the degree version is as well. It's 210. It does kind of help you make sense out of it a little bit, but don't write 210 down. Okay, we just know in the back of our minds it's 210. So we're trying to figure out 7 pi over 6. And we're doing the sine. The y value is negative a half. Now we're ready to go. Now, once we remember what radians are, and we remember that sine is y over r is always 1, it's as simple as this. This question is essentially saying what is the sine of 210 degrees? Well, then what we can do is we can say at 210, the y value is negative 1/2, and we're done the question because r is 1 and dividing by 1 doesn't do anything. We move to the next question. Okay, so letter E says what is the cosine of 3 pi over 2? And again, now we no more panics. We know that this is radians. We find 3 pi over 2. And if you look down at the bottom, that is actually 270 degrees. Again, don't change anything. If you need to, off to the side or in a margin, you could just write 270 if it helps you stay calm and see things clearly. And then we just go and we stick to our guns. Cosine is x over r is always 1. And we look down at the x value, it's just a 0, and that's the exact value. No calculator needed. We do another tangent. So letter F, our tangent question is, what is the exact value of the tangent of 11 pi divided by 6? And just before I finish this question, a note about when it says exact value. Whenever it says exact value, it really is saying don't use your calculator. You will use the unit circle or a different means if you had it, like using special triangles. But since that is not widely promoted, we will use the unit circle. So step number 1, tangent is y over x. We find where 11 pi over 6 is, it's 330. And again, if you wanted to write it down off to the side just to keep yourself calm, go ahead. I'll remember that it's 330, tangent is y over x. And let's get things in the right spot. The y value is negative 1/2. The x value is positive root 3 over 2. So in this case, yet again, what we need to do is we need to take one fraction divided by another, and so we need to flip our values. We will take our first fraction. This time I'll leave the negative alone. And dividing by the fraction root 3 over 2, well, we multiply by the reciprocal, and yet again, the 2's cancel out. But here's where we're not done. We have a value of negative 1 over square root of 3. We are not going to leave it because we have finished pre-calculus 20. We know what the word rationalize means, which you will see in the PDF notes. Rationalizing means to eliminate all radicals, top and bottom. So this will come back to you fairly quickly. What we simply do is we multiply by root 3, top and bottom. If you only look at the red, we haven't really done anything but change its shape. I'd like to jump around in front of the class right now. Anything divided by itself is 1. Again, we're just changing its shape, not its value. When you multiply the top, we have a negative root 3. The denominator, root 3 times root 3, yes, it's root 9, it's 3. We'll jump right to the 3, and now we are done. Now, here's where our finishing question comes in, and then I'll outline where you're going to find today's assignment. Our finishing question is a good one that will make so much more sense when we do chapter 5. It is, what is the exact value of the tangent of pi over 2? And we start off, again, always writing down what the ratio is. Tangent is y over x. Never ever miss that spot. We find our unit circle, and the y value is 1, because pi over 2 is 90. If you can put your eyes at 90 degrees on your unit circle, the x value is a 0. Now we're at a very, very important moment. You cannot divide by 0. The answer is not 0. It is an error in your calculator. That's a very big difference. Do not write down an answer of 0. And now here's where you're starting to have a clue what this is. If you remember back to pre-calculus 20, dividing by 0 graphically, you are basically saying there is a vertical asymptote there. And when we graph tangent in section 5.3, you will see that. Now, for your assignment today, on the PDF notes, it says first sheet number 5, all sine, cosine, and tangent. On one of the last days that I saw you, I think it was on that Monday before school was done, I had given you guys a booklet, and number 5 is on the first page. It's just all together. You will do every exact value, sine, cosine, and tangent, and the answers you'll be able to find in a further page. The questions that have SEC, CSC, and COT you do not do. Tomorrow you will learn what they are. They are the reciprocal trig ratios.